Welcome to my podcast. Today's episode, Hidden Costs of Next.js Nobody Talks About. Welcome to today's episode. Let's talk about a topic that's been quietly frustrating developers for years, the hidden costs of Next.js that nobody seems to mention. Next.js has become incredibly popular, and it's easy to see why. You write standard React code, and suddenly you get blazing fast applications with server-side rendering and static site generation built right in. It feels almost magical, and it's become the go-to choice for React development. But as with any powerful tool, there's a shadow side. While everyone's celebrating features like the island's architecture or the ease of server actions, many teams are hitting unexpected roadblocks. They face bottlenecks, rising server bills, and hours spent debugging. These aren't framework bugs. They're the real costs of building with a server-centric approach in a world that's mostly client-focused. Let's start with the bundle size paradox. Next.js lets you move heavy logic to the server, so the initial HTML load is small. That sounds perfect, right? The browser gets a fast start, and the server handles the work. But here's the catch. While the initial HTML might be light, the JavaScript needed to make the page interactive can grow surprisingly large. When you use server components, you can import libraries that would normally bloat your client bundle because those libraries never reach the browser. But any interactive part, like buttons or forms, must be marked as a client component. That means adding a special import, using the useClient directive, and including the full React runtime and all dependencies for that specific part. The hidden cost? Architectural complexity. To optimize, you have to carefully slice your UI into what they call islands, deciding which parts are static and which need interactivity. If you're not careful, you end up with a fragmented app where JavaScript is split into tiny pieces, or worse, a monolithic bundle where you've imported a huge library on the server, but still pay for shipping a small piece to the client. And this fragmentation can actually increase the total payload. You might think you're saving bandwidth by not sending the whole React tree, but too many islands mean the overhead of managing multiple hydration points and the React libraries for each can outweigh the benefits. It's not just about kilobytes. It's about the mental load of building a codebase that balances server rendering with client interactivity. Now, let's talk about costs. Many teams assume that once they build a Next.js app, hosting costs are fixed. That's true for static sites, but not for apps using server-side rendering or edge middleware. Every time a user visits your site, you're paying a server-side rendering tax. Unlike traditional client-side rendering where the browser does the heavy lifting, with Next.js, every request triggers server-side code to generate HTML. On a standard Node.js server, this means your CPU is working hard for every page load. If your app uses database queries or third-party services during rendering, the server waits for those to finish before sending a response. In high traffic, this can lead to CPU throttling or require expensive, high-memory servers. And if you're using edge functions, there's a new problem: cold starts. When an edge function is invoked, it has to spin up a container, load dependencies, and initialize the environment. For complex apps, this can take hundreds of milliseconds. Sudden traffic spikes can cause latency spikes or timeouts as the infrastructure struggles to keep up. The result? Server costs often scale linearly or even exponentially with user growth, not because of more users, but because of more server-side renders per user. Unlike a traditional SaaS product with a flat monthly fee, a Next.js app can become a pay-as-you-go nightmare if you don't closely monitor server execution time and database connections. Next up, the hydration mismatch. This is React's core requirement. The server and client must render identical HTML. It's what makes Next.js fast and SEO-friendly. But this creates a debugging nightmare. If the server and client disagree on even a single character, like a date format, the hydration fails and React throws an error. These errors are often subtle. They might happen when using random data, timestamps, or client-side libraries that don't exist on the server. For example, if the server renders a date as Tuesday, October 24th, but the client formats it as Tuesday, October 24th, due to a locale difference, hydration fails. Or if you use a date library like datefns only on the client, The server sends raw text while the client tries to format it, crashing the page. Debugging is tough because the error might appear after the page loads, or only on specific devices or browsers. It forces you to constantly question, is this logic running on the server or the client? Is that API call happening during build or render? This turns simple components into complex orchestration of server and client logic, increasing development time and bug risk. Finally, let's discuss server actions. They were introduced to simplify data mutations, letting you define functions directly in components instead of separate API routes. It feels like a win for developer experience. No CORS headaches, no separate endpoints. But this abstraction comes with a hidden trap. Server actions are essentially remote procedure calls over HTTP, hidden behind a thin layer. While coding feels faster, debugging becomes slower and harder. You lose visibility into the network layer. You can't easily see HTTP status codes, headers, or response times. If a request fails, you might not know if it's a network error, server issue, or validation problem. You rely on error boundaries and try-catch blocks inside the action, making logic harder to follow. Server actions also risk security. Because the action is tied to the UI component, it's tempting to access sensitive data directly in the component tree, bypassing a dedicated backend. This can expose sensitive logic in the client bundle. And moving to this architecture makes scaling harder. Complex workflows might chain multiple server actions together, creating tightly coupled dependencies. Changing the API later means updating multiple files across your app, leading to a tangled, rigid structure that's hard to maintain. Next.js is a powerful framework that has truly revolutionized web development. It offers features that can dramatically improve performance and user experience. But it's not a silver bullet. The hidden costs, bundle size complexity, server-side rendering expenses, hydration debugging challenges, and architectural entanglement are real and can impact your project's success. Mastering Next.js isn't just about learning the syntax. It's about understanding these trade-offs. You need to make tough architectural decisions, monitor server costs, optimize bundle sizes, write defensive code for hydration nuances, and treat server actions as a tool, not a crutch. Maintain clear separation between concerns. Don't just build for the Hello World demo. Build for the production environment. Audit your app for these hidden costs. By understanding the full picture, you can leverage Next.js's power without falling into the traps that leave teams frustrated and budgets stretched. The goal isn't just to ship a fast website, it's to ship a sustainable, maintainable application. That's the real key to Next.js success. Thanks for listening to my podcast. Visit gladlabs.io for more episodes, articles, and insights.
See you next time.